So just a plug. Starting the second week of April, Saturdays and Sundays from 10 a.m. to 4 p.m., there are volunteers with spotting scopes trained on eagles' nests. So if you happen to be going for a walk along the beautiful trails there, stop on by. Happy to check them. It's kind of fun to see them grow up over 2 months, and you say, "I remember you when you were this big," and there you are flapping your wings. That's kind of fun. And the Orange County Audubon Society, we have a lot of things coming up. I'll be leading a hike with them tomorrow at 4 p.m. What I like to do on the first Tuesday of the month is to meet where 6.5 Station meets the Heritage Trail. So I know there is an Audubon, uh, there's another parking area a little farther up, but this area has enough parking to accommodate everyone. So we like kind of like the trails there. So tomorrow at 4, for anyone who's interested, we'd love to see you. I have Barbara saying she's going to guide us to the barred owl's nest.
Yeah, I hope so.
Okay. Well, that's the story I hear. So that's the story we're going with. So whether it be, with some of these organizations or on your own, I hope you get out in, our beautiful environment to enjoy this wildlife. Well, there's so much wildlife that the thought was after last semester when we focused on birds, well, let's kind of survey everything and just tell all of their stories. And so tonight, I wanted to go with the reptiles. Although, as you maybe heard in the song, I'd like to start with a different word, the word amniotes. Because if we were to put all of these groups, like all these living things together and start putting them in biological packages, like which group do you belong to? There's some that are the vertebrates, but then within them, there are the jawed vertebrates. And within them, there's the bony vertebrates. And within them, there's the ones with 4 feet that come out on land. And then within them, there's the amniotes. Now, the amniotes include me. And I love biology, but I am a little egotistical. Like when something includes me, I just like it a little more. So this discussion of reptiles isn't just about reptiles. Like if you're interested in yourself, the first amniotes are the ancestors of the reptiles alive today, but also the birds and mammals alive today as well. So I love newts, and you can see the little red F's running around, and they're good on land. But when they want to mate and have babies, they go back to the water. Toads are really good at living on land, but when they want to mate and lay eggs, they go back to the water. All right, they have to keep their skin moist because a lot of them have to breathe through their skin because their lungs aren't very good. So while the amphibians we discussed before, while they are land animals, they're not great at it. All right, they could be better. And so here's a pair of water snakes. I just want to focus on the water snakes. They live in water, hence their name. But if they want to have sex and lay eggs, they actually come out on land. So notice the difference there. All right, so we have, amphibians that live on land most of their lives. They have to mate in the water, but here's the reverse. And it's not just they have this weird snake stuff. So if you ask, how could they do that? Well, it's because, the males have a penis. All right, the females can have a clitoris. And when you start looking, it's like, wow, well, that's something that mammals and birds can have. And that's because the first reptiles were not only the ancestors of these snakes, but the ancestors of modern birds as well. And we could just welcome, come on in.
I would love to come in. I just have a question.
Okay.
Are you using the lab right here?
Oh, we were borrowing chairs if we have overflow.
Oh, okay. Yeah, just remember to close it.
Okay, I will close it, yes.
I got to stop by sometime.
Okay, sounds good. Okay. Sounds good. If you were a salamander, you would be breathing through your throat, which doesn't work very well at all. All right. But if you're a reptile, the way that you breathe is you make your chest bigger and air comes in, you make your chest smaller and air comes out. And we realize, oh, wait, that's the way that we breathe. And if you breathe better, well, then guess what? You don't have to breathe through your skin. So your skin can do something else. Instead of being moist to let, gases pass, you could put hair on it. You could put feathers on it. You could put scales on it. And so these early reptiles, they made advances at living life on land. Their backbone got firmer. They modified their kidneys. They did all these things. And that applies to the snakes and turtles and crocodiles that we'll talk about today. But it also applies to the birds and mammals who are just as much descended from these first reptiles as we are. Now, Here's just like focusing on the reproduction again. There's toads mating in the water. There's the newts reproducing in the water. But when it comes to the birds, the reptiles, and the mammals, their embryos are wrapped in membranes, 4 of them. They are called extraembryonic membranes because these are the cells of the embryo, but they don't make the embryo's body. All right, so this is a baby cat, all right, and it's got this membrane around. And if we were to say, well, let's take a lizard and look at its membranes, let's take a horse, let's take a person, the colors would be the same. All right, there would be a yolk sac in all of them. There would be an allantois to store urinary waste in all of them. There would be a red chorion, which would either perform gas exchange through an egg or form the fetal part of a placenta, if this is a mammal. And then there's an amnion that surrounds the embryo and fluid. All right. So hence the groups that have these membranes, they can develop on land the way that the fish and the amphibians couldn't, because they have an amnion and those other extra embryonic membranes. Hence we call them amniotes. All right. Now, I would love to talk about the anatomy of the amniotes. I mean, that could be classes in and of itself because every part of it, the skull bones are a little bit more like my skull than the amphibians were. The vertebrae are a little bit more like my vertebrae than the amphibians were, and we could talk all about that. Same with the muscles. But let's just jump into the groups. About 300 million years ago, we have what we call a reptile. Now, it's kind of tricky in that they actually still had fish scales on their underside. And they had a number of traits which amphibians have. So when reptiles first appear, there are 0 turtles, 0 snakes, 0 lizards, 0 crocodiles, 0 dinosaurs, right? And the ones that are, like, again, they have amphibian features, but nevertheless, they start to have the features that only the amniotes have. Now, during this time, amphibians can be 12 feet long. So amphibians, living on land, at least the wet places of land, they're big. These are little insect eaters. All right, they're a foot long. But that actually kind of makes sense in that if you're going to transition from like needing water to develop to developing on land, if your eggs develop quick because you're so darn small, then you could like maybe lay your eggs under a moist log. And that would, you could develop before it dried out too much and you had trouble. So you'd expect big changes like that to occur in smaller animals first. But when reptiles first appear, they do not rule the world. The amphibians do. But they've made some changes which will make them adapted to living in more terrestrial environments. And so then things would change. All right. So there's lots of littleish ones for a while. But then reptiles do something that no amphibian does. All right. Reptiles say, hey, look at all this green stuff. You can eat this. All right. We don't have amphibian herbivores. All right. I mean, like there are fish that eat algae and things like that. But as far as who eats the plants, that's an amniote thing. And if you're going to eat the plants, as you know, you can get big, and that's even better because you have all this room for intestines. So there's a bunch of armored reptiles that appear early on, which are eating the plants. They have this bony armor in the skin. They have some horns. They can get to be 12 feet long. So now all of a sudden reptiles, they get to be huge. We could go on and on about these. But we get to an awkward question. I mentioned this before that sometimes the anatomists who study the world and the geneticists who study the world don't agree with their conclusions. This would be something that they've been arguing over for at least 30 years. If you were to classify turtles, all right, where would you put them in the reptile family tree? Anatomically, you would say, well, that one I just showed you had bones in their skin, all right? Kind of like, the bones in the skin that will make up part of a turtle shell. I think turtles belong in that part of the family tree. All right, the geneticists come along and say, no, they don't. I think they're kind of in the lizard, group, which, I mean, the genetic evidence is strong, but the anatomists stroke their head and say, doesn't make sense. So anyway, so that's been a discussion for 30 years. I don't think I'm going to resolve it tonight. And so turtles come about. but not for a really long time. I'm just trying to hit the groups in order, but not chronological order. If if reptiles are appearing like 300 million years ago, 50 million years go by without a turtle. When turtles appear, look at that. Big, thick ribs, because that's what makes a turtle shell. Ribs stuck to bones in the skin. So if you got really thick ribs and you got bones in the skin and they smush together, you've got a shell. All right. So we have a turtle with half a shell. It has a shell on the bottom. All right. So it actually has a shell on its bottom, what's called the plastron, but it doesn't have a shell up top. It just has thick ribs. So it's got half a shell. It still has teeth. All right. It's got a bunch of primitive characteristics. And so we look at it and we say, wow, you're like in the middle. You're this transitional almost turtle. So before there are any modern turtles, there is Odontocheles, and another one called Proganocheles is a little more modern and has a complete shell. It comes a little bit later. All right. So I'm going to jump back and forth a little bit. Just I'd like to, once I hit a branch of the family tree, I'd like to follow it to the modern day and then just jump back and eventually we'll get to the dinosaur. You had a question? Ooh, oh, such a good question. I've got a video. Just let me see if it's in this. Oh, yeah. Okay. Great question. Can we'll get there in just a second, if that's okay. Um, we're in the age of dinosaurs here. I've skipped a bit and we'll go back and revisit. By the middle of the age of dinosaurs, we have two groups of turtles, what we call the pleurodires and the cryptodires. And the second group, the cryptodires, by the Cretaceous, they learned to pull in their necks. And you're thinking, don't all turtles pull in their necks? And the answer is no. So if you look at turtles alive today, there are two groups. One are called the side neck turtles. So reptiles first appear in the Carboniferous. The primitive turtles are first occurring in the Triassic. The pleurodires are coming afterwards. And if you ever go to a zoo, you might see something like that. So that turtle doesn't live around here. It lives in southern areas. This is one of the side neck turtles, once again, incapable of pulling its neck inside its shell. So this is a little bit older than the branch of the turtle family that you know. And on southern continents, there's a lot of these. And if we were to look, we could find some which are endangered, and I have videos about this, so like that species there, right? This part of Colombia is the only part of the world where you can find it. All right. So, a lot of, these, as we go through these groups, one reason to be interested in them is, the biodiversity of the planet is being threatened. So that, is another thing that we could consider. But let's go back to the types of turtles that more, the cryptodires that can pull their heads inside the shell. Now, one of the things about turtle shells, which you very astutely pointed out, all right, that very few people know, is getting up bones in your skin is not hard. I mean, actually, that's how we got our skull. All right, so my arms and legs, they were cartilage first, and then they gradually became bone when I was a teenager. But this, when I was a fetus, I started making bone here, and it just got bigger. So we all know how to put bone in our skin. That's how we got this. And then different groups of animals say, well, if I know how to do that, why don't I just do it here? In addition to there. Now I've got bones in my skin like a crocodile would, or an armadillo would, or armored dinosaurs would. So it's not hard to have armor. I mean, you already know how to do this. If you just do it different places, you're good. So that part isn't hard. The hard part of a turtle shell actually is my shoulder is outside my rib cage. A turtle's shoulder is inside its rib cage. All right, because the shell is in part turtle. So that's actually a tricky question. How could that happen? Well, we have the same story told by both fossils and turtle embryos. So the story goes like this. All right, so a normal amniote, the shoulder blade is here, the scapula, and then you've got ribs and muscles there. All right, and so the arm, notice the shoulder is outside. But in both fossils and turtle embryos, these ribs are short, at least at first during development. And while they are short, then this scapula kind of then, instead of staying there, migrates inside so that the same muscles are used, all right, but now the shoulder is inside the rib cage. So we have turtles where we see shorter ribs here, and the scapula is beginning to migrate, and we can watch that happen in embryos. So that's a great question that you had. This seems to be the mechanism through which that happened. So in the cryptodire group that started then branching out, they then have different groups, and we have different ones today. So there are two members of this family in North America. We're getting there. The Chelydridae gives us the alligator snapping turtle, the largest turtle in North America, freshwater at least, that you can find if you go in the Mississippi River. All right, they like to sit at the bottom, they open their mouth, and their tongue is like this little fleshy thing that flops around like a worm, and then fish come and think they're going to eat a worm, and then the snapping turtle just eats them. So this thing is huge, all right? And we do not have the alligator snapping turtle in our area, all right? But we do have our snapping turtles. So let me just kind of do a little aside. We'll jump back and forth as there we go. So here we have snapping turtles. You may see them soon, all right, because once again, they will lay eggs on land, even though they'll live in the water. So you may see them crossing the road. You may help them cross the road sometimes, but obviously you have to, they don't like it when you hold their tail. Is probably not the best way to do it, but you have to kind of keep them at arm's distance because they do have a long neck and they can snap. All right. So maybe you get to see them crossing the road. And if you kayak, all right, or canoe, not just yet, but like in a month, look for this because snapping turtles mating, comes closest to like the wrestling of dinosaurs that I think you're ever, and it'll go on for like an hour. All right. And they'll probably both be bleeding by the end of it. All right. But anyway, so this is just kind of going on in the background. I've got more in the videos, just they kind of roll and tussle, et cetera. So, we can see these multiple areas here. Snapping turtles are the largest turtles in our area, and they eat a lot of things. Like they eat a lot of baby birds, like baby ducks are favorites of snapping turtles. In addition to all kinds of fish, baby turtles, including baby snapping turtles. At the Liberty Loop, there was one year where there was a young sandhill crane developing with the adults, and then all of a sudden, the young one wasn't there. And people had said, well, we've been seeing a whole lot of really big snapping turtles lately. So the going theory is, just a theory, is that maybe a snapping turtle managed to get the baby sandhill crane. Okay. But then there are more families of the cryptodires, which can hide their necks. And a lot of them are endangered. And so it's of interest looking for different places in the world where we can find them. All right, so, I have videos which go through those. But this is the big group of turtles in our area, including the painted turtle, which is the most common turtle in our area. There's a couple of different subspecies which can have a little different pigmentation on their underside, which is called the plastron. You notice the red and the yellow pigmentation there. Interestingly, when I spoke of amphibians last, I said there's a couple that can freeze solid. Baby painted turtles can freeze solid. And so some of them hatch, like eggs can be laid at different times of the summer and they can hatch at different times. The ones that hatched in like September, October, the baby painted turtles might have said, you know what, let's just stay in the nest. All right, the shallow little depression, let's just sit here all winter. Yeah, some of our liquids will freeze. But then spring comes and then they, go out and start foraging. They're the only amniote known to do that. So that's kind of interesting. Coloration can change. So here's one that I found, which was a little redder than usual. And then there were other species. Spotted turtles, we're a little concerned about them. Their numbers are declining. And so whatever protections you have, so like New York, you're not allowed to catch any wild turtles. Pennsylvania, you are. But spotted turtles would have more protection than the painted turtles do because we're more concerned about their numbers. There are different kinds of turtles. Some are more terrestrial, like in our area, we have box turtles. So they'll be feeding on like strawberries and mushrooms on land rather going into the water. They're called box turtles because they have a hinge on the lower part of their shell, which can kind of snap shut as a way of deterring predators. And I think I have that somewhere. We have wood turtles, also kind of threatened, that can live in more on land, right? Larger turtles with interesting coloration there. We have small burrowing musk turtles, which very often you never see because they just sit in the mud. Let me just go through the last a couple. We have, and then there's one which is really endangered called bog turtles. And there's so many plants which are modifying the habitats from purple loosestrife to Phragmites that we think that bog turtles are really being devastated. Yeah. Yeah, good, excellent question. Like the difference between like a hawk and an eagle, just turns out an eagle is a big hawk, and hawks have gotten bigger at different points in history. And we say, oh, this here's an eagle, there's an eagle, but the two eagles aren't closely related to each other. Tortoise, the same would apply. Toad, the same would apply. There's lots of different kinds of toad that aren't really related. They're just frogs that got living. Good question. Okay. So there's all kinds of turtles, and I mean, New York is, a coastal state. Some of the turtles, they elongated their digits to become more flippers. And if you were to ever to, go to the Caribbean and snorkel or scuba dive, then you could see some of the diversity of sea turtles, which we have here. So turtles have a long history going back, say 200 million years more. And I just throw that out because, we think, oh, mammals, mammals have this age of mammals for the past 60, 65 million years. That's a long time. But these groups of reptiles, they're older. All right. So the reptile rule of land is far longer than what the mammals have managed to do. There's certainly a lot that could be said. But if we're to say it in an hour, right, then we should move on. So then the reptiles, they just were doing so great. And then they did something that you wouldn't think. Then some of them went back to the water, right? And I know, like, you just adapted to land. Why are you going back to the water? But then that's not atypical. I mean, some mammals have. I mean, we have whales, we have hippos, we have otters, we have minks. So we have mammals that say, even though the mammals are good at living on land, they can also then adapt to aquatic environments. There's birds, from penguins to puffins to, the same thing. And so reptiles went back to the water and formed a big group. Now, at first they were small, like these things are like a foot long or et cetera, but they get bigger. All right, it's not going to impress you first. All right, so this one's maybe 3 feet long, about 10 neck vertebrae. All right, but from that, all right, then maybe get 20 neck vertebrae, maybe 3 feet long. Then maybe 6 feet long, 20 to 30 neck vertebrae. And then by the time we're in the age of dinosaurs, we got some of these things. They are 50 feet long with 70 neck vertebrae. So reptiles were huge. Now, we'll talk about dinosaurs, but dinosaurs are big. But the ones in the water were bigger. All right, like some of the, like this one here, Liopleurodon, its head is almost the size of T-Rex's body. All right, so like T-Rex, big animal on land, but some of the aquatic
I'm doing something.
so much bigger. And there were so many different kinds. You got the big-headed ones, you got the long-necked ones, you got the ones that look like dolphins. I swear, no, that's the wrong one. You got the ones that look like dolphins. And the neat thing is you can watch it happening in prehistoric time because the first ones don't look all that much like dolphins. All right, that comes about later. So, you can see them gradually changing. So there's all of these groups of aquatic reptiles. All right. Back on land, there's a group that gets holes in their head for jaw muscles, which is different from the first reptiles. So they're better at chewing their food. They're called diapsids. Diapsid means 2 holes. And the first ones aren't all that impressive. Like, look at that. That's a foot long. But then they spread out. And from these early things that have diapsids, we get this one little branch called the rhinocephalians. Most people have never heard of those. They give us the rhynchosaurs. Most people have never heard of those. But out of this group, which dies out, there is one thing alive today, in Indonesia called the tuatara. All right, so here's a branch of the reptile family tree. Looks like a lizard, but it's not. All right, it's an offshoot of these. Lizards, oh, we could talk about lizards. Lizards are old. All right, lizards of the groups alive today, lizards are the oldest. They're older than turtles, they're older than crocodiles and snakes. All right, we've got all these different kinds. Some of them, right, and I just to make a cultural reference, if you saw some of the newer Jurassic Parks, like all the old ones, like T-Rex was the big monster one. But some of the new ones, all of a sudden at the end, there's people surfing in a wave, and then there's like just this huge mosasaur swimming behind it, and you realize that is so much bigger than T-Rex was. They're lizards. So mosasaurs were 50-foot marine lizards. So in Tyrannosaurus Rex's day, there were lots of big predators. Lizards were among them living in the oceans. Many lizards, the majority of them, far less dramatic, lots of different, lots of great diversity there. Just, I think I can find this without wasting too much of your time. Lizards do get big, like we do have a Komodo dragon alive today. It's huge, it's big enough to eat people, all right? But its relatives got bigger, all right? So relatives of the Komodo dragon could get up to be 30 feet long during the age of mammals. So some lizards today are poisonous, all right? Some lizards can walk on their hind legs or at least run like the basilisk can, and a couple like the frilled lizards can. All right, so, lizards are very diverse. And they're also what we call a paraphyletic group, all right? So what I mean by that is if you were to study reptiles, you would say, all right, here's a lizard, here's a snake. And if you really know your reptiles, you say, oh, here's a worm lizard. It looks like a snake, but it's not. All right, so lizards, worm lizards, and snakes. But the thing is, lizards are so old. They have such a diverse family. Worm lizards evolved from these lizards. So these are lizards. These are worm lizards that don't have legs. Actually, most of them don't have legs. Some of them still have 4 feet. But these worm lizards are more closely related to these lizards than they are, than these lizards are to these lizards. And then another group of lizards decided to lose their legs. So lizards have been losing their legs for a while. There are legless lizards today. One of the ways that you can tell is if it winks at you or closes its eyelids. Snakes don't have eyelids, but lizards do. So if you see something that looks like a snake and then you see eyelids, it's a lizard. All right, so there are legless lizards, there are worm lizards, and then there are snakes. The first snakes still had hind legs, all right, actually, and one Tetrapodophis, I have a video of it somewhere, I swear. It actually had front legs too, all right, so we do have snakes with 4 legs, then we have snakes which still have 2 legs, even though the back legs are tiny. They still, nevertheless, they have a femur, they have a tibia, they have a fibula, they have the same bones as you would have in your legs. Okay. And so the first, snakes evolved from lizards. Now, let me just say something about lizards. We do have lizards living in Orange County. They're hard to find, though. They like cliffs. Like if you go to the Schwangunk Ridge, you can find them. I was hiking and I worked at a scout camp along the Appalachian Trail. And here's a cool one because it has a blue tail. So that's fun. All right. But so we do have lizards in our area. So they are native, but they tend to prefer habitats farther south of us. But especially if you're climbing in a rocky area with a lot of cliffs, you can see a lizard in here. But then obviously we do have snakes. Now, snakes are an old group, and the most primitive snakes are probably ones you don't really know very well. So there's that's a snake, believe it or not. Looks like a tiny wormy thing. Or it's called a blind snake and thread snakes. They're ones that burrow underground. Pythons and boas, they are a primitive kind of snake. One of the ways we know that snakes are, or they're primitive snakes. I swear I'll have it somewhere. All right, I guess I'll go. Is that you can still see the tiny little remnants of legs, right? So I'm going to, all right, so here's a lizard that's winking at you. So it's a legless lizard, but you can tell it's not a snake because you can see its eye. And if you were to look here at this, it was I think it was an anaconda I was looking at in South America. It was in a museum. There are two things. Let me just kind of go to the obvious one. Snakes are descended from lizards. I could give you a whole bunch of reasons to support that. You would forget all of them, except for one. So why don't we just go with the one that you're going to remember and just move on, just save ourselves some time. Lizards and snakes both have what are called hemipenes. So males have two penises, although they will only use one at a time. So here you can see the cloaca, and then here you can see the pair, all right? And a lizard would have a comparable setup. So snakes and lizards are kin, and there's all of these things with the genetic test for anatomy which would show it. But the second thing of interest is if you look there, there's a little tiny bony spur. That's a leftover remnant of the legs that the first snakes had. All right, so we have fossils of snakes with legs, and there are a couple of primitive groups that still have little tiny bony spurs where their legs once were. While I'm in the PowerPoint, South America had a lot of, big things. So like today there were rodents called capybaras or carpinchos that can be pig-sized. Their ancestors used to get to be cow-sized. Well, today snakes like eating rodents. And if you think back, well, what would have happened in the day when, the rodents got to be cow-sized? The snakes got bigger too, and the alligators that we're going to talk about, they got bigger too. And so this thing could be almost 50 feet long and weigh over 2,500 pounds. A titanoboa living in South America, eating those early mammals. Okay. Now, of the snake diversity, there's different families. So, for example, coral snakes, which don't occur in our area, all right, they are their own separate family. Most of the snakes that we have in our area are what are called the harmless snakes or colubridae. So most snakes are in this group. Now you have to be careful by saying they're harmless because they are mostly harmless. But when we think about rattlesnakes, what is venom? Venom is just modified components that were in snake saliva to begin with that now they can inject. So just harmless snakes, they have bad stuff in their saliva, but it's just what's going to affect the frog that they're trying to eat. All right, it's not really going to affect you much. But in nature, you have to beware of absolutes. You should never say this group is always, harmless or whatever, because there are a couple of harmless snakes like the boomslang. And people in zoos are like, oh, it's a harmless snake. And they can give it a bite that's dangerous that could get you really sick or even potentially be fatal. So just throwing it out that there's exceptions to everything. But these are the ones we have in our area, like these beautiful milk snakes. There's water snakes. There's garter snakes. There's black rat snakes. Now, black rat snakes, you may not have seen them, but they've seen you because one of the things they do really well is climb. All right, there's birds and birds' nests and baby birds in trees. And so, all right, they make no bones about it. They can climb, 20, 30, 50 feet up in the air along these trees. So when you're walking in the woods, there are snakes above you sometimes as they try to prey on birds. So here's just, here we watch this, and then it's just going higher and higher in the tree, right? Because, that's just what it does. It's evading predators and it's looking for food there. There are tiny snakes in our area. Here's a little ringneck snake. The only thing that could fit in its mouth would be tiny bugs. Really, really cute. Some like if you ever see these like hit by the car, it'll look kind of gray on the back, but if you flip it over, it's the red-bellied snake here. So there are a diversity of harmless snakes which you can find in our area. Okay. And then there are the vipers. Okay. So this is a different kind of snake. Now you can tell by a couple of ways. It tends to be bigger and fatter, but the head is triangular. All right. And if you look near the nose, all right, you'll see holes, pits. So these are called pit vipers. And they have a sense which makes them special. They can detect heat. So if we shut off all the lights and made this a completely black room, they could still catch mice because mice are warm. All right. And they can detect changes in temperature. All right. Like, so if you think of the movie Terminator, where Terminator was kind of visualizing the world through heat and could follow the heat sources and get outlines. That's kind of what they do at night. All right. So as the age of mammals dawned and mammals got really common, well, then reptiles got better at preying on mammals. And this heat sensing way was one of those things. So this is a copperhead. It's a pit viper with a big triangular head. And then we have, here's a timber rattlesnake as well. At some point, you'll see the rattle start to rattle, and you start thinking, who's the stupid photographer that's getting closer than he should? Be me. It was like just with the rattle, I'm like, what am I doing? I should back up a little bit. We have these are pit vipers in our area. Birds eat snakes, snakes eat birds. And so, whether you're more interested in one group or the other, they're all interrelated in nature. And then so, there are some which are eating eggs. Red-tailed hawks are really big at going after snakes, etc. All right, so we have all of these groups of reptiles. All right, but I'm going to start getting a little more exciting because I'm going to start talking about the archosaurs. Now, I can tell you're excited because you're thinking arc. All right, yeah, okay. I've studied Latin. Arch, that means to rule, does it not? I mean, let's face it. If you have an arch enemy, I'm not asking anyone to volunteer. You can keep that private. If you have an arch enemy, is that any old enemy? No, your arch enemy. That's something special. Like an archbishop. That's not any old bishop. All right. So archosaurs literally mean the ruling reptile. So by talking about archosaurs, now we're getting into a whole nother group, not the lizard and snake side of the family tree. All right. Now we're getting into the branch, which includes the crocodiles, the dinosaurs, the birds, and a couple of other things. So they start off, just kind of, normal the way that you do. But then by the Triassic period, we get crocodiles. So we do. They don't look like crocodiles. They're like a foot or a foot and a half long. Some of them are running on their hind legs. Some of them like skinny little legs. All right, so what's going on with these guys? It's like, well, crocodiles, they have a 200 million year history. They've changed over time. So the first crocodiles look very, very different from the crocodiles that we have today. Then they hit the second big phase of their history. All right, so here's like an early crocodile. Here's an early crocodile. Notice like the really thin lines, etc. All right, but then we get to the second group. All right, so the first crocodiles are here. Later, we're getting into the second group of crocodiles. And just like, it's so tempting to like rate things on how big they are. Like, oh, Tyrannosaurus Rex was this big or whatever. But there are different ways of measuring size. All right. So T-Rex was bigger than the biggest crocodilians in its day. But they were heavier. All right. So how do you measure size? All right. So like just by some measures of size, who's the biggest predator of the Cretaceous? Not T-Rex. It's the crocodiles. And interestingly, you find T-Rex in the Western United States, which is actually like its own little subcontinent at the time. It was separated by a seaway. So T-Rex rules the West, all right, the California, Oregon area. The southeast of the United States ruled by really big crocodiles, all right? So, these were quite a force in their day. So this thing's 40 feet long and would have fed on dinosaurs that got too close to the water, all right? Many of them are marine the way that the modern crocodiles, like the American crocodile is. And then just at the end of the age of dinosaurs, we start getting some of the lineages which we have alive today, and they survive the mass extinction, unlike the dinosaurs. And then they continue spreading here. This one would have stood 6 feet at the shoulder and would have been 40 feet long. Also living in the Amazon. Once again, there are rodents the size of cows. This gives us snakes, which are 50 feet long, crocodiles, which are 40 feet long, to feed on them. All right. Then there were other things, yeah. Good. That's a great question. So I can give a couple of things. The one thing we know for a fact about everything that survived is they're all small. Nothing big survived. And so, crocodiles can, there's giant crocodiles, but there's also caimans, which are much smaller. So, that might have had something to do with it. Other than that, it's hard. I mean, like birds, a lot of birds died, some birds made it. A lot of the early mammals died, some mammals made it. And so obviously they're similar. Why did this group of birds live in this group? Why did these plants live and these plants die? Good question. There are a number of crocodilians alive today, but a couple weeks ago, oh, darn it, I forgot to change the title. Okay, sorry. A couple weeks ago, I was in the Everglades, all right, where I was privileged not only to see alligators, which I've seen before, but crocodiles. They have been separate lineages for 70 million years or more. All right, so they're not closely related at all. All right, so these are different lineages. Crocodiles, all right, these are the ones where the external teeth are going to be showing, their snouts are kind of narrower. They like salt water. So this is the part of the Everglades just before Florida Bay. So this water is salty. And there you see crocodiles. Also, how I was like closer to the rattlesnake that I should have been? Probably same thing in a kayak as I was going up to this crocodile. Yeah. These we don't find them in much of the United States, only the southern tip of Florida. Or you can find them throughout the Caribbean, Central America, and into northern South America as well. Both the alligator and the crocodile were threatened, and we were worried about them, but both have recovered. Now, this one's kind of still considered vulnerable. Alligators are fine, but both are a tribute, like the bald eagle. All right, we humans are capable of putting animals in danger of extinction, but when we protect them and look after their habitats, they're capable of bouncing back. All right, so lots of birds have, from snowy egrets to all of the things that were once kept for feathers to bald eagles. Alligators and crocodiles would be in that scenario as well. So now I'm in a different part of the Everglades. This is freshwater, and that's an alligator. Has a much broader snout. Both of these often will get to be 13 feet long, but both of them, if you ask, what was the biggest crocodile of all time? What was the biggest alligator of all time? Both about the same, about 20 feet, right, and weighing about 2,500 pounds. So these, are big animals. The alligators, they don't have their teeth sticking out because as they grow up, their snouts get wider, so it covers the teeth from their lower jaws. All right, so if you were to visit the Everglades, you could see two native crocodilians, probably not in the same place because once again, one prefers saltwater, one freshwater, but maybe a 40-minute drive from one place to another, you could, see those. Okay, so crocodiles are archosaurs. And then there were others. So this looks like a crocodile, but it's not. All right, it is an archosaur. But if you look where its nostrils are, it's not at the tip of the snout, it's right in front of the eyes. So like an alligator, if it's trying to sneak up on you, it has to have all of its head out of the water. Its eyes and its nostrils are at opposite sides. But if you have your nostrils right in front of your eyes, you don't have to have much of your head outside of the water at all. All right, so most of your snout's underwater. So they would have been dangerous predators here. And then there were a bunch which just kind of looked like dinosaurs. All right, we call them Rauisuchians. Now, you might not care about Rauisuchians, but just a quick comment. The age of dinosaurs, the Mesozoic era, is broken up into three periods: the Triassic, the Jurassic, and Cretaceous. Dinosaurs ruled, but only in two of the three. In the Jurassic and the Cretaceous, dinosaurs ruled. The Triassic is where we get the first dinosaurs. They didn't rule yet, all right? And they had company which were bigger than they were. There were lots of big reptiles in the Triassic. The dinosaurs were just one of multiple groups. But there was a mass extinction at the end of the Triassic period. These would be other conversations, so let me just kind of give you the 30-second version. At the end of the Paleozoic era, ending 250 million years ago in the worst mass extinction in the past 500 million years, Africa hit us. Or maybe we hit Africa. I wasn't there. I don't know whose fault it was. But in any case, the continents collided. And what was the bottom of the ocean formed where we are now. The Appalachian Mountains, the Shawangunk Ridge, the Kittatinny Ridge, the Catskills, the Adirondacks. This was the bottom of the ocean. He's not here, is he? No. Oh, okay. So there was a gentleman at one of the first talks here who who at the end came up and said, hey, I've got this big rock that has fossils in it, who very kindly, thank you so very much, who very kindly last Friday brought this really big fossil full rock up, and the geology club, you might have heard them from your house. They were just like, you had 20 kids just banging and banging and banging on this. It was loud. But anyway, pulling fossils out of it, it was really cool. But the point is, the fossils were from the bottom of the ocean. Orange County was the bottom of the ocean in the Devonian. All right. But when these continents collided, it pushed the land masses up, forming the dry land and the mountain ranges, which we had. So that was a mass extinction, and there was no Atlantic Ocean. Africa was like a 2-hour drive from here. But 50 million years later, the continents decide, nope, let's undo that. And then they started to split. So Africa and North America go their separate ways. There's volcanic activity all up and down what would have been the East Coast, and the Atlantic Ocean starts to form. Another mass extinction, because, just crazy volcanoes, etc. Dinosaurs were one of many before the mass extinction. Dinosaurs ruled afterwards. So a lot of these Triassic reptiles did not survive that mass extinction as the Atlantic Ocean starts to form again, but the dinosaurs did. Dinosaurs had cousins that deserve mention before I get to the dinosaurs. All right. Now, they could fly. They were the first vertebrates to fly. Bugs were the first animals to fly. All right. But this group, called the pterosaurs, they were the first group to fly. Now, at first, I'm not all that impressed, because if that's a reptile's arm, that's my arm, there's a pterosaur arm. Look, all the bones are pretty much the same, with the exception of this wrist bone getting real weird and long. All the bones are the same. Look, they're all the same colors. All right, they got fingers just like you. What makes them so special? Oh, yeah, wait, I'm sorry. I left out a finger. Finger number 4, this one. So if we put finger number 4 on that, you now see why they are able to fly. All right. So that's their 4th finger. If you had a 4th finger that was that big and thick, and you had a patch of skin that stretched the side of your body, well, I'm sure you could do some fun things too. All right. So pterosaurs develop the ability to fly, and they are the first vertebrates to do it. And if you can fly, you can avoid predators. But up until this day, a bug that takes off into the air, it's on base. Nobody can get it. Fish, once they swim out in the middle of the lake, they're on base. You can't get them. Flying chases everything. You can fly over the lake and grab them. A bug starts flying away, you can chase it. All right, so this was an incredible thing for the reptiles to do. So reptiles are the first flyers here. Okay. And there are 2 groups of these pterosaurs. The first group, small wingspans. I mean, some you could have held in your hand. Some have like a 1-foot-long wingspan, 3-foot-long wingspan. They were small. And then later, there are big ones. So these could be the size of like World War I planes, 40-foot wingspans, and the like. They're doing great. However, by the middle of the Jurassic, group number 2 evolves flight. Now, there's a bunch of things that can glide. Squirrels can glide, some marsupials can glide, some frogs, some snakes, a whole bunch of things can glide. But who can fly? A couple of dinosaurs at least glide, maybe fly weakly, but not a group, not a big group, just kind of like an oddball here or there. So like, let's put them aside. 3 groups have evolved flight. Pterosaurs were number 1, bats were number 3, birds were number 2. And birds are just better than the little ones. All right, because like if I'm a pterosaur, I hate mosquitoes. All right, or there probably weren't mosquitoes yet, but in the early one, but by the later ones there were. I just got skin here. Now some of their skin was covered with a fine fur, but that makes me really vulnerable. But also, like if I go running in the woods, like branches hit my face, I have scratches all over the place. But imagine you got wings and are flying through this underbrush. You're going to get scratched or whatever. Birds have much shorter wings covered with these protective feathers. They were just better. So as birds, increase, these small pterosaurs decrease. All right. So bird success was at the expense of the group that beat them to the air. All right. But the really big ones will last until the end of the age of dinosaurs, the ones which can have the 40-foot wingspan. And so then the last group of reptiles I'd like to discuss, because I'm going to skip 2. I skipped, we'll see the dinosaurs, which are closely related to birds, but we already kind of talked about that, so no need to repeat that. And we will be talking about mammals soon. So I have skipped the group of reptiles which gradually becomes mammal-like. That's a fascinating story, but that belongs in another lecture. So the dinosaurs, this is where our story ends tonight. All right. So reptiles did not exist at all in what's called the Precambrian, which is most of the history of life on Earth. When vertebrates start in the Cambrian, it's just fish. And we get jawed fish, then we get bony fish. Then in the Devonian, at the very end, we get amphibians. All right, in the Carboniferous, we get reptiles for the first time, but they're the little ones. Reptiles aren't really, holding their own and eating plants and doing stuff like that until the Permian. And then there's that mass extinction, which ends the Blue Paleozoic era. This is when the continents come together. And then we have the Mesozoic era, sometimes called the Age of Reptiles or the Age of Dinosaurs. That there's a mass extinction at the end of the Triassic, and after that, the dinosaurs rule. Where did dinosaurs come from? Well, I would be happy to go into that story, but the thing that makes a dinosaur is not its head. Some of them had cool heads, like T-Rex had a huge head. Some of them had horns on their head. Some of them had head-butting heads. Some of the cool heads, but the heads come later. What dinosaurs start with is the way that they ran. They were all bipedal at first. And if you look at their legs, all right, they got a short femur. There's the knee. There's the ankle. So their ankles are high off the ground. They're running with just their toes on the ground. And some of you are saying, wait, didn't you say that about birds? Yeah. All right, birds evolved from dinosaurs. They have feet like this. But it was the way that they moved. I would be happy to go into this. This would be 20 minutes of itself, talking about here's a reptile, an archosaur that sprawled on the ground, had a lizard-like body. Here's one related to dinosaurs and crocodiles, which can hold its legs under it like a dog. Ooh, and look at this pubic bone. Look at the ischium bone getting a little longer. Ah, that's interesting. Look at this thing. Looks like a dinosaur, but it's not. It's an almost dinosaur. And the things that make dinosaur legs special, we could just trace them. And when you could say, ooh, you see a little here, a little more there, a little more there. And there's a group of reptiles called dinosauromorphs, gradually becoming dinosaur-like. The first dinosaurs are small, 3 to 6 feet long. They're all bipedal. We don't have horns yet. We don't have armor yet. We don't have plant eating yet. They're just generalized. All right. So the world is full of big, scary reptiles. Dinosaurs look like this. And then from the beginning, all right, we tend to split them into 2 groups. Now, what I'm about to say, this is not perfect. All right. But we'll go with it. I think it's here. I'm sorry, I have too much stuff here. Oh, too many groups of dinosaurs. All right, so we want to look at their hips. Okay, that's the one. So here's the top part of the hip, the kind you feel in your belt loop. But you have 2 bones called an ischium and a pubis, but they're small. All right. Here, the ischium sticks out and it's almost as long as the thigh. Here, the pubic bone sticks out and is longer than the thigh. So that's a weird dinosaur hip. And, that's one of the things that makes them special. But notice that in this dinosaur, the pubic bone goes forward. Okay. In this one, the pubic bone is going backwards. All right. So we split the dinosaurs into, quote, the lizard hipped, with the pubic bone going forward, and then the bird hipped, with the bones going backwards. Now, this is not a perfect system, because some of the lizard hips then switch their bones here and then make a bird hip and actually become the birds. So the birds are not bird-hipped dinosaur descendants. They are lizard-hipped dinosaur descendants, which just switch their pubis, but that's another story. Okay. In the lizard-hipped group, all right, we have, they're called saurischians if you care. All right, we have these 2. Now, that's what they look like in the mid-Triassic, and they look the same. They don't look exciting, but we have 200 million years to go. And so this will ultimately give us the meat-eating theropods and the long-necked sauropods. All right. Meanwhile, the bird-hipped groups, they will then give us, oh, I'm sorry. The bird-hipped groups, oh, I'm sorry, we're still in there. All right. They will give us the horned dinosaurs, the duck-billed dinosaurs, the pachycephalosaurs, the armored dinosaurs. Now, they all look different now. But if you were to start here, once again, in the Triassic, look at them at the beginning. They don't look different. They're all bipedal. They're all little things, bipedal, don't have specializations yet. So the things that make many of the groups distinctive develop slowly over time. Let's see some of those. So in the Triassic, some of the meat-eating theropods start to get bigger. And you would know this if you went to Connecticut, where we could find Dinosaur State Park. All right, so it's kind of this cool building where there's just this trackway of this big Triassic dinosaur running across, Connecticut and presumably Orange County as well. All right, would have looked kind of like Dilophosaurus. Okay. Now, what I'm about to say, I'm sorry. I hope I don't offend anyone. The Flintstones lied to you. Okay, I'm sorry. When you watch the Flintstones, everyone lives together. All right, there's the person, there's the saber-tooth tiger, there's the pterosaur, there's the dinosaur. Didn't happen like that. And then even all the dinosaurs didn't live together. So meat-eating dinosaurs, the theropods, when do they live? Well, there's a lot of them. T-Rex only lived at the very end. So dinosaurs are around for 160 some million years. All right. T-Rex only saw the last 5. Most dinosaurs never saw a T-Rex. All right. There were dinosaurs only in the Triassic. There were dinosaurs that only lived in the Jurassic. There were dinosaurs in the early Cretaceous. So as we go through these groups, they were quite diverse. All right. Some of them, develop big teeth of the meat-eating dinosaurs. Some develop, they lost their teeth. All right. Some developed claw-like arms. T-Rex, lost most of its arms because its head was so darn big it didn't need arms. One group, as you know, that's a dinosaur hand. That's the hand of a dinosaur. But if you were to hold up the wing of the first birds, you say they have exactly the same bones. All right. And so one group of these theropod dinosaurs gets fluffy feathers, and then they get flight feathers on their tail and arms for whatever reason. And then some of them actually were capable of gliding and maybe even weak flight, all right, and would become the first birds. All right. So we talked about these before. All right. This is a bird, but it's got teeth. It's got long clawed grasping hands. It's got a long reptilian tail. The first birds came from these theropod dinosaurs. But there was another group of saurischian dinosaurs called the sauropod lineages. When the sauropod lineage first appeared, small bipedal. But once again, they're coming in after a mass extinction. Who's eating the plants? A lot of plants on Earth. No one's really eating them much. So they decide, all right, that's going to be what we do. And if you eat plants, you can get bigger. And they got bigger and bigger and bigger. And at some point, then they said, we're so big, we're going to spend some of our time walking on all fours, sometimes standing so we can reach the highest branches. All right. And then some of them said, well, we got bigger still. All right. And now we're going to be 4-footed all the time. So there's this group called the prosauropods, which has small bipedal forms, 3 feet long. And then ones which are like 10, 15 feet long, which could be quadrupedal sometimes, bipedal other times. All right. And then you got the really big ones, all right, which then are on 4s all the time. And it's from these big prosauropods that then we get the sauropods, all right, the largest animals to ever walk on Earth. One in South America, actually, we know got to be more than 100 feet in length. Now, they didn't all weigh the same because there were different lineages. Some could be long, but they were fairly lightly built, while others were dense. All right, so once again, if we want to talk about who's biggest, some of the ones were not quite as big, but they were a lot heavier than some of the other ones. And if you go to Dinosaur State Park in Colorado and Utah, Utah is where the big entrance is. You see this kind of like, you see this kind of just this rock wall, and you can see dinosaur heads, including a sauropod, Camarasaurs, head still embedded in the wall. All right, so you can see them here, and a lot of the museums around the world that have great dinosaur fossils came from this rock formation out in Utah and Colorado, including this one that you can see in the main area of the Museum of Natural History in New York City. So we are an hour away from a huge sauropod fossil that was found out here in Dinosaur National Park. So that's kind of fun if you go there. Okay. And then we have the other group of dinosaurs, the bird hip ones. At first, not so exciting, small, bipedal, and the like. All right. But then some said, ooh, we already know how to put bone in our skin, and crocodiles do that after all. Why don't we just do that and do it more? And so some put a little armor in their skin, some put a little more, and then they started getting heavier. All right. So now they were more likely to spend time on all fours. Some of these then would develop just like a tank-like apparatus where they would just cover themselves in bone. Some had club tails, some didn't. Or as a group called the nodosaurs look like this that didn't have club tails. The ankylosaurs had club tails. The stegosaurs, they had spikes at the tips of their tails. Okay. One of the things which was significant is the ability to chew. If I were to say, you chew your food and wait for excitement. Okay, I don't see excitement because, a lot of you are thinking, wait, doesn't everything chew its food? The answer is no. All right, think about how birds eat or frogs or crocodiles. Chomp, chomp, and swallow. In a shark's gut, you find whole fish or half of a fish. They didn't chew their food. Mammals chew their food. And these dinosaurs did. So chewing is unusual. Most animals don't. And so if we were to watch this one lineage, all right, they go for like a gazillion years, but they're very gradually moving, changing their teeth. So at first they just have like one tooth row, the teeth don't touch, nothing special. But by the end, they can have 2,000 teeth in their mouth at a time, row after row of teeth, all cemented together for just this grinding platform that can just pulverize plants. It takes tens of millions of years to get there through gradual stages. And this gives us the duck-billed dinosaurs. They, at the end of the Cretaceous, they are doing great. Them and the horned dinosaurs diversifying everywhere. So much so, if you were watching the song earlier, there's so many, like, how do you know who to have sex with if there's duck-billed dinosaurs everywhere you go? Well, their heads all have these different shapes, meaning that they would have made different sounds. Just as birds today make different calls and the females can say, that's not my male, that one is. All right, these duck-billed dinosaurs would have been able to do the same because of having all of the different shapes of the crests of their heads. Right, we can go back to the song at, as you leave here, but there's Parasaurolophus, there's Corythosaurus with a dome, etc. Another group also got good at chewing their food. They got a parrot-like beak, and then they decided to just make the back of their head a little bit thicker, making a frill. All right, so we have these little guys that have frills, but that was a good thing. This thing could probably be 9 feet long. And then after that, all right, once you got these frills, they said, well, if we throw in horns, you got the whole package. And so then they became the horned dinosaurs. But once again, evolved very slowly, where chewing comes first, these frills come later, and then all of these horns. Once again, they were really successful at the end of the age of dinosaurs. So when we ask, why did dinosaurs die? It wasn't that like this weak lineage was, gradually dying out and mammals were eating all their eggs. They were doing great. The horned dinosaurs were diversifying like nobody's business at the end. The duck-billed dinosaurs were diversifying like nobody's business at the end. So then what caused the end? All right. Well, I mean, lots of things certainly, but none of them like really hold up, like as far as the explanation, like all the dinosaurs die out at the same time. Yeah, the climate was changing, but I mean, dinosaurs have been around for 160 million years all over the planet, from the Arctic Circle down to Antarctica. They can live in different temperatures. You might say, oh, the mammals were eating their eggs. Well, as we can discuss later, mammals actually appear in the Triassic. All right, dinosaurs rule for like 160 million years with mammals under their feet, and the mammals can't do nothing. All right, so I'm sure a lot of things could affect dinosaurs. All right, but there are two things which really seem to have been bad, and the fact that they happened at the same time probably is significant. India. I don't mean to point fingers, but like, what is India thinking? It's part of Africa for the longest time, and then decides, no, don't want to do this anymore. I want to be part of Asia. So for the longest time, India is stuck to Africa, part of the giant supercontinent called Gondwana in the south. But then it moves as fast as continents ever have, as it goes north and will ultimately slam into Asia and form the Himalayas. There were volcanic eruptions, not the biggest in Earth's history. They would have been in Russia at the really big mass extinction, but these would have been the second biggest in Earth's history. So the first biggest volcanic eruptions happened at the time of the worst mass extinction ever. The second biggest volcanic eruptions occur at the second biggest mass extinction. So the Earth was being poisoned by volcanic eruptions, which were just continuing for tens of thousands of years. Dumping carbon dioxide in the air, heating the planet, making acid rain, doing all of this stuff. And right at that time, a rock falls out of the sky. big rock, maybe 5 miles long. Now, maybe it was a meteorite, maybe it was a comet, we could argue. But something big hits the point where Mexico meets Guatemala. 65 million years ago, there's a crater there. And that probably threw so much stuff up into the air that when it came back down, the surface of the earth probably became as hot as a pizza oven. All right. And just not everything died, but 60% of life did. All right. Some birds made it, most birds didn't. Some plants made it, most plants didn't. We could go through all of the groups. And in the aftermath of that, dinosaurs are gone. All right. However, just last statement, reptiles ruled the planet for 300 million years. And it was two really big things, like huge volcanic eruptions and a big rock falling out of the sky that did them in. All right. And this would start the planet cooling. All right. So like ice ages, that's a recent thing. Dinosaurs never saw ice. There wasn't ice at the two poles during dinosaur days. All right. No polar ice caps. So cooler planets just don't favor reptiles the way that it favors the furry ones and the feathered ones. So reptiles have not gone back to their, a previous stature. But if you go to like the rainforests, reptiles are doing great. I mean, there's snakes everywhere. There's big crocodilians everywhere. So it's not as if reptiles aren't successful today. They are. And final statement, the birds evolved from reptiles. All right, mammals, as we'll see later, evolved from reptiles. So those early amniotes, 300 million years ago, their descendants have ruled. They've traded places. There have been things before the dinosaurs. There were the dinosaurs. There are things after the dinosaurs, but they're all amniotes. All right, so that was one of the most significant groups to appear in Earth's history. So as you get out, I'll get the question. I hope you enjoy seeing all of the reptiles basking, the painted turtles and the like, maybe snapping turtles, laying their eggs. We'll be talking about plants and fungi next week, and we'll get to mammals shortly after that. If anyone has any questions, please feel free to stay and ask. But thank you so very, very much for coming. And I apologize. I'm going to answer questions in a second. I just need a quick read. Yeah, so yes, what's your question?
You haven't mentioned cold-blooded versus warm-blooded, reptiles versus mammals. Did that affect survival in any significant?
Oh, I'm sure it does, as it does today. So that's a tricky thing to talk about, because on a warm day, a reptile could actually have a warmer body temperature than me, but sitting in the sun. So it doesn't mean that it's cold. It just means that it doesn't regulate its temperature. The outside air does. But if you work at a zoo, we can keep 40 big crocodiles on the amount of food it takes for one tiger. Right? There's a price to being warm-blooded. It's expensive. All right. If I'm going to be 100 degrees in February, if you were to heat your house to 100 degrees in February, you'd have a huge bill. That's expensive. That's what you do to your body. All right. Reptiles just don't do that. So there are pros and cons. So if you can get food, all right, if you're warm-blooded, you can hunt at night, you can hunt in the north, you can hunt all winter. But if you live in the tropics, all right, it's already hot. You don't have to heat yourself, but now you need less energy to get you through a day. So mammals aren't as common in the tropics, and the reptiles are more. So there's a whole bunch of things coming into play. And warm-bloodedness can actually come in stages. Platypuses are not as warm-blooded as you are, but honeybees, they're a little warm-blooded. Dragonflies are a little warm-blooded. Some sharks are a little warm-blooded. Like when you're cold, you shiver and you warm up. Bees do that. On a cold morning, they're shaking and they warm up warmer than the outside air. So it's not as if there's, in nature, we like to say, oh, here's a cold-blooded box, here's a warm-blooded box. There can be a little bit of, gray area in between. Good question. Yeah, I'm sure it has a lot to do with a lot of things. You had a question?
Is there any truth to that? I've heard a theory that after that impact in Mexico, what went up came back in the form of fused silica glass.
Yeah. Yeah. So we can find that. And that's when I said, that's what heated the planet. All right. So all of this stuff coming back down, it would have been like, ooh, like meteorites, like you just see the height. If that was just happening everywhere, just all of a sudden the whole atmosphere would have just been, cooking. And yeah. And they can find microtechites and these small silica blobs all over the world at exactly the same time, and a spike in a radioactive element that we associate with meteorite impacts called iridium. All right, so you go to Australia, you go to North America, like the sediments are different because different things were going on. But 65 million years ago, everyone on Earth was undergoing the same thing. Yeah, so it was something global. Anybody else? It's wonderful to see you. Have a wonderful evening. Yes. Oh, thank you. Thank you. Yeah.
So I think they can pass the third, but while it was still migrating, I guess I assumed that now it's in place, but,
The Himalayas were what happened. And the Himalayas are still rising because India, I'm sorry to be like, what's it thinking? It's still going north, but Asia's in the way. And that's why, like, every now and then there's an earthquake or whatever, because India is still moving. And there's, in Pakistan, especially, you can still have earthquakes as these tectonic plates push against each other.
if we have time at some future lecture, can you address the organisms that were on this graph that was reported?
Yeah, I would love that. India was like a little floating continent. I know very little. I know stegosaurs, the ones with the spikes on their tail, they die out in the Jurassic, except in India. You can have some living in the Cretaceous. So India was a floating island and had unique life. That's a great point. I should research more about it. I don't know that much, but that's a great point. Have a wonderful evening, everyone.
Thank you.
Have an osprey at Walton Lake today.
Oh, cool.
Yeah, every once in a while I'll see one.
Mhm.
The other thing on the Cornell app for bird sounds,
Uh-huh.
an American woodcock.
Ooh, oh, they're neat. A lot of
Haven't
people,
seen
if you're in bird groups, woodcock walks are the thing. So if you get a chance to do that, I think Sullivan just did. I think Orange County Audubon, Diane Tuttle, I think, is going to lead one. That's not actually tomorrow evening after our hike is over. I'm going to go up to see if I can find any woodcocks here at 6.5 because we do have a grassy area. Just it's this really cool thing where the male woodcocks will like fly up in the air and try to court the female. They're around at dusk, but they make this sound called ping, ping, ping. And so like if you're walking in a grassy area and you hear that, that's a woodcock. And so woodcock walks, this is the time of the
This
year
was
for
at Goose Pond Mountain Sanctuary,
it.
like between Chester and Monroe, right on 17M.
No, it's right on 211, the place where we usually go.
Okay, this was where I was.
Hey, take care.
It's pretty cool.
Oh, okay.
Listed anywhere.
They were, Diane was talking about, we had a board meeting 2 nights ago.
She might like
Yeah. So,
keep checking.
all right, I'll email her now and ask her to.
One last thing, the other bird we heard at our house was a yellow rump warbler.
Ooh, oh, wonderful.
Didn't
Yeah.
see him yet. It's the app
Yeah.
was there.
So if you ask who are going to be the 2 first warblers to come here, yellow rumped and palm warblers, and I saw palm at the Delaware this weekend, and you saw yellow rump, so they're a little earlier than usual, but they are the 2 that you expect.
Regarding woodcocks also, they're in Bryant Park in the city.
Oh, okay.
I had no idea, I just saw something about it, yeah, and they're organizing walks too.
They usually come out at night, so they can be in areas and you're not as familiar.
Twilight.
Yeah.
Yeah, well, these just returned to Bryant Park. I was gonna
The,
try
the
and see
cool
them.
thing I like about woodcocks is their eyes are farther back on their head than any other bird.
Weird.
Because the reason is they have this long beak and they're hunting for earthworms.
Right.
So they spend all this time with their beak in the dirt. So it makes them really vulnerable to predation. So their eyes are like way far back on their head to the point where their eyes, like part of their brain has actually moved. The cerebellum has actually moved to fit their eyes back there. So it's kind of neat.
Very cool.
Like my back.
Ah,
6.5 Station Row.
Yes.
We finally went and looked and we found it.
Uh-huh.
And